This is a walkthrough of Problem 1 on Exam 2 of Module 1 in the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 1 on an Exam 2 in an FA-18 Hornet jet takes off from a Nimitz-class aircraft carrier. It has a distance of 80 meters to get up to a speed of 260 kilometers per hour from rest, assuming the acceleration is constant. What is the acceleration in units of meters per second squared? This acceleration cannot be provided by the engines of the plane, so they catapult the plane up to speed before it leaves the aircraft carrier. Here's the diagram. Speed is 0 at the beginning. 80 meters later, it's going 260 kilometers per hour. There's the distance. Now let's think. Well, before we can think, let's get those units of 260 kilometers per hour into meters per second, and then we can better think about the problem. The speed is 260 kilometers per hour. We multiply by 1 twice. 1,000 meters is 1 kilometer. 1 hour is 3,600 seconds. The hour units cancel. The kilometer units cancel. We end up with meters per second. And that's 72.2 meters per second, which is, of course, pretty fast. Now we can think about what's going on. Accelerate smoothly, constantly. We're making that assumption. Let's guess 3g for the acceleration. 3 times the acceleration due to gravity, and then we can wrap our head around what's going on here. 30 meters per second squared. Let's assume the acceleration is 30 meters per second squared and think about what happens. If it ends up at 72.2 meters per second, it starts at 0 and changes speed 30 meters per second every second. It's going to be at 60 meters per second after 2 seconds, 90 meters per second after 3 seconds, and roughly 2.4 seconds, it'll be about 72.2 meters per second, which is 260 kilometers per hour. The average speed during the acceleration starts at 0, gets up to 72.2 meters per second, is about 36 meters per second. If it averages 36 meters every second for 2.4 seconds, that's a bit more than 80 meters. That's really close. That was a lucky guess. The answer is going to be pretty close to 30 meters per second squared, 3 times the acceleration due to gravity. So now we can actually do the problem. We can calculate it. The most convenient equation to use, since we don't have the time and we do not care about the time, is v final squared equals v initial squared plus 2ax. V final we know, 72.2 meters per second squared. The initial speed is 0. The distance is 80 meters. We can solve this equation for a, and we get 32.6 meters per second each second, which is about what we thought. That will put your eyeballs in the back of your head.